So this video is going to talk about stratospheric ozone thinning. And so in your notes, you're going to kind of fill in as we go through this. So first thing in your notes talks about layers of the atmosphere. And so here are layers of the atmosphere. Ground level is the troposphere. The next layer up is the stratosphere, then the mesosphere, thermosphere. Sometimes you'll see an exosphere also in there. But those are your main layers. Honestly, the big two that you need to know is troposphere is ground level. Stratosphere is where the ozone layer is. Troposphere, that's where weather happens. That's where global climate change happens. Most things happen in the troposphere. That's where most of the gases, even though the layer is not that, doesn't look that thick on this scale, because of pressure, that's where most of the air molecules are going to exist. So that's the troposphere, the ground level. And then above that is the stratosphere. Big idea with the stratosphere too. You don't need to write this down, but that stratosphere is about 0.6 parts per million ozone, which is 0.00006%. So very, very, very small concentration of ozone in the stratosphere. And we'll see why that's significant in a little bit. So what does the ozone layer do for us? The properly functioning ozone layer basically absorbs ultraviolet radiation. And we're going to talk about different types of radiation in a minute. You don't need to write down these equations, but it does this whole series of reactions basically where it's broken into what are called free radicals, and those free radicals form. But big idea, again, it blocks and absorbs this ultraviolet radiation. What is ultraviolet radiation? The next slide there's the electromagnetic spectrum. You can see in the middle here, there's visible light. And with the visible light, that's what we can see. Lesser than that, so here's visible, and then less than that is infrared. And that's when we talk about global climate change. We're concerned about infrared, which is basically heat. And then above the visible, so the visible spectrum, red, orange, yellow, green, blue, indigo, violet. Above the visible is violet, hence the name ultraviolet. This has more energy. This is what's going to cause like sunburn and things like that. Ultraviolet, you'll notice it's kind of a whole range here. It's not just one little narrow section. So ultraviolet actually is broken into 3 different categories. They have UVA, which has the least amount of energy of all of it, but it's actually linked with something called melanoma, which is a very deadly form of skin cancer. Most of this goes through the ozone layer. So the ozone layer doesn't really absorb UVA. There's UVB, which is kind of the middle amount of energy. The last one will be UVC. And it is linked, UVB is linked with some skin cancers like basal cell carcinoma or squamous cell carcinoma. Those are skin cancer, but they tend to not be as deadly as melanoma. And then the ozone layer does absorb most of that. And then UVC, which has the highest amount of energy, causes sunburn. And the atmosphere, meaning oxygen gas, which again, 21% of the air is oxygen gas. The atmosphere will absorb most of the UVC in addition to the ozone layer. But again, since it's 21% oxygen gas kind of takes the energy out of UVC mostly. So although UVC, and I'll move my image here, although UVC has the highest amount of energy, oxygen gas absorbs it. And again, 21% of the air is oxygen gas. So thinning of the ozone layer really causes the issue with the UVB. So the big idea, it's the UVB that starts getting through more when we have thinning of the ozone layer. So what does the ozone layer do for us? The ozone layer filters out, in particular, UVB radiation, which is linked with basal cell carcinoma and squamous cell carcinoma. Here's kind of just an image showing what's the difference. So UVA, and they're showing different sunscreens and things like that. But again, the wavelengths for them, UVA, a little bit less energy because it's a little bit shorter. You can see the wavelength here is 400 to 320 nanometers. And so it's actually a little bit longer wavelength, which makes it a little bit less energy. But again, the UVA can penetrate a little bit deeper, and that's why it's linked more with melanoma versus the UVB doesn't tend to penetrate quite as much. So that's some of the issues you see with the UV. With that being said, then what issues are linked with that. So I'm going to show you some images here. So again, this is kind of the table. So UVA, B, and C. So energy, the highest is C and the lowest is A, and B is in the middle. The health-related issue, UVA is linked with this melanoma. My husband actually has a fair number of moles on his body. So he goes to the dermatologist and they look at those moles, and sometimes they're like, we think this one looks a little funny. And they chop off a little sample of it. He hates going to the dermatologist, and then they test it to make sure it's not melanoma, because melanoma kind of looks like a mole and it's kind of has these unfinished edges. UVB is linked more with a basal cell carcinoma or the squamous cell carcinoma. And you can see like this image of one of those. Sometimes people have those, and you'll hear about people maybe getting things removed that would be associated with those. So those are the related health issues. And again, UVA goes through the ozone layer. That's why they're going to talk about using different sunscreens for it to protect yourself, because again, it gets through the ozone layer. UVB is what the ozone layer filters out, and UVC, essentially oxygen gas, which 21% of the air is oxygen gas, filters it out. So the properly functioning ozone layer, these are two really, really important equations. So here we have ozone, O3 is ozone. So I have two ozones, and what happens is the UVB splits this up and breaks things apart, and through a whole long series of reactions, you end up with 3 O2s. Then the reverse of that is UVC can break up oxygen gas and convert it back into ozone. And so what's happening is this is a cycle. You're forming oxygen, and then the oxygen is going back and is forming the ozone. So that is a properly functioning ozone layer. Since ozone filters out UVB, okay, so notice the ozone here filters out the UVB. If there's less ozone around, more UVB reaches the earth. So super important equations. There's a whole bunch of other equations, but you don't need to memorize and know those equations. So in your notes, that is these really important equations. That is the top of page 2. So be sure you write those down and know those. Those are super important equations. And again, why is it that the ozone is so critical? Here's the ozone, and it's such a small amount of it in the ozone layer or in the stratosphere that a little loss of it and now more UVB can get through and cause some of those skin cancer issues, squamous cell, basal cell carcinoma, etc. The UVC is basically taken care of by O2, and again, 21% of the air is O2. So what are the human and environmental consequences of ozone layer thinning then? So the ozone layer blocks out UV, in particular UVB. And so if we reduce if we reduce the ozone layer, the concentration of ozone goes down, what's going to happen? Human health, you're going to see increased instances of sunburn and skin cancer, in particular the squamous cell carcinoma and the basal cell carcinoma. Also in humans, you're going to see more eye disease, in particular cataracts. This is actually one of the things with cataracts that they suggest is that you actually wear sunglasses that have a UV 400 protection so that it blocks everything out. So here again, what are cataracts? People often ask. You see old people wearing glasses like this at times. Basically, and that's kind of a picture of a cataract, their lens gets cloudy. They can have surgery and get their cataracts taken care of, but then they tend to be more sensitive to light. That's why they often wear glasses or sunglasses that look like this. So your eyes are a very sensitive tissue, and so the stronger UV is going to damage your eye tissue and cause cataracts. So those would be your human health issues. Your environmental issues are going to be just like it's more sensitive plant tissues, more like our eyes are more sensitive. It's going to damage tissues of plants, and that could reduce photosynthesis, in particular, more sensitive plant tissues. Where we're seeing thinning of the ozone layer the worst, and we'll talk about why in a little bit, but where we're seeing thinning of it the worst is in polar regions. And so there's like phytoplankton near the poles are much more sensitive to UV radiation. And in fact, if you think of like fair-skinned people like myself, I tend to sunburn very easily. And so polar organisms tend to have fairer skin, and so they're more susceptible to getting that tissue damaged and things like that. So that is essentially what is one of the concerns with um, the environmental impacts of ozone layer thinning. I'm going to stop this video there, and then I'm going to continue with what causes the disruption and some of the other issues in the next video. I think I am, at least.